It'll catch up with me when I'm 70. I get pneumonia. All right. Related rates. Today we're going to talk about something that is, like I said, it's going to take 3 days. This is part of your AP content. This is part of just regular calculus as well. This isn't specific to the AP test. These are word problems. Is there anything about you that guarantees that you're going to just know how to do every problem? No. In fact, you finally kind of gotten that point, haven't you, where you realize that there's no guarantee that you understand the material moving forward, right? I mean, it's a challenge. As you talk to some teachers, they'll tell you that their math career ended with, say, calculus or calculus 2 or something like that. And so it's okay if you're hitting points where you're saying this is challenging. Let's look at this situation. I'm going to draw a box because that's what I do when I encounter word problems all the time. It says the area of a circle increases at a rate of 20 inches squared per minute. At what rate is the radius increasing when the radius is 5 inches? So what's happening with related rates is there are things that are changing and they are related to one another. For example, if the area of a circle is changing, what other things are changing as well? The circumference of the circle is changing, the radius of a circle is changing, the diameter is changing, and also another thing is changing, and that is time. So as time goes by, these things change. So I'm going to draw just a picture in the first one. We have a circle that's increasing. The area is increasing. So I usually model the problem in the first box. The second box, I write a formula. I also write knowns and unknowns. So if I'm looking at the area of a circle, what's the formula for area of a circle? Area is equal to pi times your radius squared. What are some of the givens or the knowns that I have in this problem? What's that? So r is equal to 5. Known and unknown. So the area of the circle increases at a rate of 20 inches squared per minute. What does that mean? The derivative of the area, a prime, is equal to 20. It says the area of the circle increases at a rate. That means at a rate. At a rate means a derivative. And so here's what I have. What we do in this box is we take the derivative with respect to time. And now my computer's mad at me. So we're doing math that's too difficult, so it won't. No, come on. Okay, we're going to take the derivative with respect to time. Take the derivative with respect to time of a is equal to pi r squared. Do you see the time variable show up in my formula at all? No. So let me try to help you understand how you've done this before. We've taken the derivative, and so far we've basically always done it with respect to x. And say we had y squared is equal to x squared plus 2x plus 3. When we took the derivative with respect to x of y squared, do you remember what you got? 2y y prime is equal to. So when you didn't have this variable, you had to attach a y prime, right? But when you did have this variable, you didn't have to attach an x prime, did you? So that's what we learned with implicit differentiation. In this type of problem, we don't have a t at all, do we? So you need to attach an a prime, an r prime, all those type of things. So the derivative of area is 1, then you attach an a prime. Pi is just a number. It's constant, comes along for the ride. What's the derivative of r squared? And you have to attach an r prime. And in this box, we solve. So we take our a prime is equal to 2 pi r prime. And for a prime, we have 20. 20 is equal to 2 pi times r. What is the current r value? 5. For 20 is equal to 10 pi r prime. Divide both sides by 10 pi. We get 2 over pi equal r prime. Now, it is a rate. Let's make sure we attach the appropriate label. What is the radius measured in? Inches per what? Minute. Now, some people said that they thought it should be inches squared. We measure area in inches squared, right? We don't measure a radius in inches squared. Just it's linear. It's one dimensional. So we just have to the first power. Okay. All right. So you know that formula for volume or area of a circle. Let's go with one that you may not remember as well. Basketball is being filled with air at a rate of 1 cubic centimeter per second. At what rate is the radius increasing when the radius is 12 centimeters? So again, I like to draw a box, and I'm not very good at drawing spheres. I guess that's my best bet. So I'm going to list my formula. What's my formula for volume of the sphere? I'm just trying to draw a sphere. You can draw it however you want. You don't need to make fun of mine. So, good. That's my formula for volume of a sphere. This is one you're going to want to write down because you need it. The surface area of a sphere is equal to 4 pi r squared. And we'll list some of the others, but wherever you want. Somewhere where you can remember that the surface area of a sphere is 4 pi r squared. Okay, so let's list some of our knowns and our unknowns. What are we given in this problem? R equals 12. What else? V prime is equal to 1. What's our unknown? What is it we're trying to find? Because it says a basketball is being filled with air at a rate of 1 cubic centimeter per second. Volume, because it's to the third power, so that's the measurement. If you just think of the act of filling a basketball with air, it's a three-dimensional figure. Rate of means derivative. So, and then we have, we're searching for r prime. It says, at what rate is the radius increasing? That's what we're looking for, is r prime. So now I'm going to take the derivative with respect to time of volume equals 4 over 3 pi r to the third. What is the derivative with respect to time of v? V prime equals what? 12 thirds is 4 pi r squared r prime. Good. You've got the idea that you need to attach an r prime and a v prime and stuff like that. So now I solve in this box. So we have v prime is what? 1 equals 4 pi r squared. So I need to solve that. Divide, or we got 1 is equal to 4 times 144 is 576. divide both sides by 576 pi. We get 1 over 576 pi is equal to r prime. Now on the test, you can write it in decimal form, or you can write it in terms of pi. So that's 1 over 576 pi what? What is my label? Centimeters per second. Now, all the problems that we've done so far, these two, they're all what I refer to as level 1 problems. Okay, all right, yay. All right, we'll enjoy the ones that we like, okay? We're going to get some more challenging problems here very quickly, okay? Let's set up 3 and then you'll go to lunch. We'll come back and finish it. We just have 2 more problems that we want to do together today. You guys have a short assignment that's fairly straightforward. You should hopefully get today's assignment very well, and then the ones after that you might struggle with more. So a right triangle has a base of 12. That remains constant while the height and area increase. So I have a triangle. What's changing with the triangle? Height and area and what other part of the triangle would be changing? There's 3 legs to a triangle. Base, height, and starts with an H. Hypotenuse, thank you. So those are changing. Is the base changing? So I'm going to do something different in this drawing. Because the base does not change, I will put a 12 there. Notice how before it said, well, when R is 5. Well, yeah, but R was changing, so I didn't put a 5 in for the radius right away. It's constantly changing. But this does not change at all, does it? Okay, so it's getting larger. We have the area of a triangle is equal to what? 1/2 base times height. And because the base is 12, I can say area is equal to 6h. So when you know that it remains constant, you can plug it in right away. Go get your brain some food, come back, and we'll continue. Okay, here we go. We set up a formula for the area of a triangle. In this case, it's going to be 6 times the height. What are our knowns and what are our unknowns? Yes. A prime is 8. What else? What else? A is 64. Current area is 64. If we know that the current area is 64, could we figure out the current height? We could. I'm not going to do that because we might not need it, but you could. And then what are we looking for? What's our unknown? What are we trying to find? Well, the current area is 64, but it's changing. The formula for the area is 6 times h. So we could use that in order to figure out the current height. So what are we looking for? We're looking for h prime. It says at what rate is the height increasing? So I take the derivative with respect to time of a equals 6h. What's the derivative of a? What's the derivative of 6h? No. So now I solve, and a prime is 8 equals 6h prime. So I didn't need the current height. I didn't need the current area. All I need to do is divide by 6, and I get 4 over 3 is equal to h prime. Or 4 over 3, what's my label? Centimeters per second. Now, part of the deal is that as I'm giving you these problems, again, these are all level 1 problems. You notice how nice it is that we didn't have to go back and solve for anything else. we didn't have to do a substitution at all. So in your assignment today, I'm going to have you guys practice one of those problems right now. But then after I give you a little bit of time to practice, we're actually going to do example 8 together. So um, I will turn to that, but I'll show you your assignment here that you can start on right now. All right. Volume of a ball is increasing at a rate of 10 cubic centimeters per second. At what rate is the diameter increasing when the volume is 100 cubic centimeters? It shouldn't say 100 cubic centimeters per second. It just is 100 cubic centimeters. So one change I need to make for next year. Won't be the last. We're doing 8. This is what I refer to as a level 2 problem. Level 2 problems are very indicative of what you'll see on the exam and what you're going to see on your test in this class. Level 1 problems should be pretty straightforward. Level 2 problems, a little trickier. As you can see from your worksheet, we also have level 3 and level 4, ones that are much more challenging. So, we go to work. I have a ball, and it says the volume is increasing. And I know that the volume of a ball or a sphere is equal to what? Now, I think it's problem 3 in your assignment that says the surface area of a sphere. So you need, again, that's 4 pi r squared. If you don't know one of the formulas, your calculus book has some in the front and the back, and obviously you can go to Google and figure it out from there. So what are our current knowns and unknowns? V prime is equal to 10. Good. V is equal to 100. Those are our two knowns. What's our unknown? D prime, thank you. Not just diameter, D prime. I need to know the rate at which the diameter is changing. Now, look at this. When you take the derivative, are you going to come up with a D prime? No, why? There's not a diameter in there, is there? So that's a problem, folks. We've got to write a formula for volume that instead of being in terms of R is in terms of D. So there's a relationship between R and D. Namely, that diameter is equal to how many radius? 2R. So divide by 2, and 1/2 of a diameter is equal to a radius. So I'm going to take this, and I'm going to substitute it in for R. Now I'm going to use some space in this third box over here to actually write out the equation and then take the derivative. So volume is equal to 4/3 times pi times, what is 1/2 d to the third power? 1/8 d to the third power. So volume is equal to 4 times 1 over 3 times 8. 4/24 is 1/6. So if I take 1/2 d and I cube it, I have to cube 1/2 and I have to cube d. So we got 1/6 pi d to the third. That is our formula for volume. Now I will take the derivative with respect to time. What's the derivative of v? V prime equals 1/6 will become 1/2, because you're going to bring the 3 in front, 3/6 is 1/2 pi d squared d prime. So good, that's my derivative. Now we're going to do our final solving here. V prime is equal to 1/2 pi d squared d prime. So what I need is I need to substitute, let's see, I know V prime. V prime is 10 equals 1/2 pi. And I want to solve for d prime, but I don't know d. Do I? What to do, what to do. What, Annika? Plug in the 100. So what Annika is saying is that we know that volume is equal to 1/6 pi d to the third. So if the volume is currently at 100, we can plug it in here and solve for d, and that will give us our current d value. Correct? I'm going to need some scratch paper to do that. 100 is equal to 1/6 pi d to the third. I will multiply both sides by 6. 600 equals pi d to the third, or 600 over pi is equal to d cubed. So I will now cube root both sides. I will cube root both sides. So 600 divided by pi, and we're going to take that to the 0.33 power, 1/3 power, and I get 5.76 is the current diameter. We're okay with how, that's what D is, 5.76. Because you got to cube root both sides. It's D cubed. So cube root is 0.33 power, 1/3. So here's my problem, and I put in a 5.76 squared. Do it when you want. It's free country. So 10 times 2 divided by pi, and then I'm going to divide it by 5.76 squared. I got rid of the 1/2 by multiplying both sides by 2. I divided by pi. I divided by 5.76 squared. Yeah, 0.19 is equal to, and on the AP exam, they're going to go to the nearest thousand, so let's do that. 0.192 is equal to d prime. So 0.192 what? What? Okay, so your assignment is the worksheet, problems 1 through 7. Um, but you guys, you're just going to keep a running tab of all these problems. We're not going to do all 22. I'll give you a choice of which ones to do, but we will eventually for sure have you do all 1 through 12. Okay, so after tomorrow, you'll be able to for sure do 1 through 12, and even some others. So we will do a lesson today. We're done. We'll do a lesson tomorrow, and then Wednesday will be our last day of related rates, and you should be able to clean stuff up over the weekend.